Hey everyone, and welcome back to NDC. Now, SwiftUI doesn't include a built-in audio player, so today we're going to build our own from scratch using AVFoundation. So here's a little preview of what we're going to be building today. We have a pause and play button. When we play, we can have the music playing, and we have a left and right visualizer, so the sound coming on the left and the sound coming on the right. You can see as the song plays, it kind of moving and grooving a little bit. We also have a slider to adjust the volume here, as well as a scrubber, so you can jump ahead in the song and also track with the little timers to see where we are. I've also added a little bit of extra flair through an animating gradient background that when we pause, it goes to being static. So we have built AVFoundation audio recorders and visualizers. Now it's all about the output. This way you can create your own custom playback engine that feeds live data into SwiftUI to animate a visualizer. So if you're interested in building this or learning how to adapt it into your own app, maybe you want to create your own little audio player, let's go ahead and dive on in. So I'm going to be starting off in Xcode, so you'll need Xcode installed on your Mac, and we're going to be creating a new project. For our project setup, we're going to be using the iOS app template today. And for our product name, let's call it Playback Visualizer. Of course, name it whatever you'd like. For the interface, we're going to be doing SwiftUI and language Swift. We don't need any testing systems or storage today. Now let's go ahead and create that wherever you normally save your projects. I like to do it on my desktop. Okay, once we've loaded in our project, before we get to coding, it's usually a pretty good idea to add your audio files to Xcode. Now you can either grab a link or you can download one from the internet. I would suggest actually using the YouTube Studio for royalty-free music, especially just for testing. I'll put the link to this in the description below, but we can just go ahead and grab and download a random song here. You can always check the license type, but these should be completely free to use. All right, once you've downloaded your MP3 file or your WAV, we're going to go ahead and drag and drop it into the left side where we have our project navigator in our folder of Playback Visualizer. It might take a second to load, and you're going to want to copy the files to the destination and make sure your app is the target, and then hit finish. You'd even test the audio. You can even open it with music, but we should be good to go. I just grabbed a random one off of the YouTube music. Now I'm going to also rename this file because, typing that out would be pretty annoying. So I'm going to call this one test_audio, and I'm going to leave it as .mp3. Much easier for us to reference in the code later. Okay, before we create our content view, we need to create a backend where we're going to be creating an audio engine. So we'll create a class and we'll make it observable so we can easily connect it to any one of our SwiftUI views. So let's create a new empty file and let's call it audio engine. Wonderful. So we're going to do a couple imports. The first one's going to be AVFoundation. The second one is going to be SwiftUI. And the third one's going to be Combine. Next, we're going to create a final class. And we can give it a name. I would recommend calling it just something like Audio Engine. And we're going to conform this to be an observable object so SwiftUI views can react to publish changes. So when we have playback, meters, and even the time. Go ahead and add our brace and hit return. Now we're going to create some published variables. So we'll do the @publish to create these, and we'll use var for variable. The first one we're going to create is playing. We're going to set this to be false. This is going to drive UI state, and we're also going to use it later for our background animation. Essentially just a Boolean flag to see is it playing, true or false. We'll then create another published var. This one is going to be the current time. This way we can track where we are in the MP3 file. And this is going to conform to a time interval, and by default we're going to have it be at 0.0. Now we're making it a double so we can track the seconds. We'll create a third published var, and this is going to be for the left power. So today we're going to be looking at the left power and the right power. In your app you might want to look at treble, bass, just other kind of cool things you could do with the audio. We're going to keep it pretty simple today. So this is going to be a float, and by default we're going to have this be -160. So this is going to be the peak power, or the dB, for the left channel. We're going to create another published, and this is going to be another variable, and this time we'll do the right power. Another float, which will also have equal -160 for the peak power of the right channel. Now we're going to create some variables for the underlying system audio player. We're going to keep it private in order to control any access. So we'll create a private var and we'll call it audio player. It's going to conform to the AV audio player. We're going to mark that as optional. We'll then create another variable for a polling timer. This way we can update meters and current time while playing. We'll create another private var and it will be a timer, which conforms to the timer, also optional. And let's add another variable, this time for duration. This way we can expose the duration very safely. This is going to conform to a time interval. We're going to add our argument braces, and for this one, we're going to be looking at the audio player, dot duration. We're going to provide it with a default fallback of 1. We're going to put it to 1 to avoid any division by 0 in sliders, just like a, good safety measure there. And because we're eventually also going to be controlling the volume, let's create a variable for the volume. This is going to be a float. We'll add our argument braces, and from here we'll be getting and setting the volume. So we'll add our get with our braces, and we'll be looking at the audio player dot volume, and we can provide it with a fallback or a double question mark, and we'll set this one to be 0.5. Then we'll be setting, and from there we'll be looking at the audio player once more, dot volume, and we're going to have it equal a new value. So that'll allow us to control the volume, and we'll also be avoiding any leaking to the audio player reference. Okay, now that all of our variables are set up, let's go ahead and initialize. We're going to do a basic initializer, nothing within the brackets. Instead, in the braces, we're going to have our guardlet. From here, we're going to have a URL, and we're going to be looking at the bundle because we're including this one locally, .main.url. We're going to choose the for resource with extension. For the resource, we're going to grab the exact audio file name. Always feel free to copy and paste this, just in case you're playing something and it's not appearing. We're gonna put in test_audio. And for the extension, we can go ahead and include what it is, MP3. As we learned from our video one, this is case sensitive. So if your extension is like MP3 like so, make sure you're handling it accordingly. I could see mine on my desktop is the lowercase MP3, so we should be all good to go there. Because we're using a guard, outside of our brackets, we'll add an else in our braces, and we will be returning. So this essentially just loads the bundled demo audio. Still within our initializer, we're going to add a do, and we're going to be referencing our audio player, and we're going to have it equal try AV audio player. And from here, we're going to be looking at the contents of, which is going to be that URL we had just created. This is going to create a player from the file URL, in our case, that test MP3. Then we're going to have our audio player once more, this time with the question mark, and we're going to be looking at the .prepare to play. This is going to preload and buffer anything for a quicker start. And then one more reference of the audio player, .is metering enabled. We're going to be setting this to be true. This is going to enable us to look at the power level metering. Outside of the do, we'll create a catch for any of our errors, and we can just print those to the console. We can just say error initializing player, and we can string interpolate whatever that error is by just referencing error. Cool, so that is our final class audio engine. We have pretty much set it up. This handles the file loading, prepares the player, and enables metering so we can read live volume data. Now let's add some of those playback controls and a timer to update our visualizer. We'll probably do it roughly every 20 times per second, but we can always play around with that value. Okay, so after our initializer, but before the very last brace in our class, we're going to be creating some functions. Let's create the first function, or I guess methods in this case, of playing. And this is going to start the playback and begin any periodic UI updates. If you follow along with my input audio visualizer, you'll probably see a lot of common themes here. So we're going to be referencing the audio player .play. Afterwards, we'll be having our isPlaying to equal true, that Boolean flag that we had. And we're also going to be starting a timer. Now this is a function we have yet to create, so we will have an error for this for a while, but this is going to be used to start pulling any meters or time. Since we just created play, let's also create the function to pause. We're going to be referencing our audio player once again, question mark dot, and this time we're going to be doing the dot pause instead of play. Our is playing is going to be false as it's no longer playing, and then we're going to be referencing another function we haven't created, which is going to be the stop timer. Don't worry, we'll be creating both of those functions next, so let's do it. We'll be creating a private function to start the timer. Empty brackets, go ahead and add our braces, and from here we're going to be having a timer equal the capital T timer. We're going to be doing the dot schedule timer with time interval and repeats. So for our with time interval, we're going to be doing it every 0.05 seconds. Then for our repeats, we can set it to be true. You can update this time interval as you'd like. I just find that 0.05 works best for me, and we don't need this block autofill. Outside of the timer, we're going to go ahead and add a brace, and we'll do underscore in. We'll hit return a couple times here, make a little bit of space, and we'll have our self.update visualizer, another function that we need to definitely create. But essentially, this is our drive metering at about 20 Hertz for smooth animations with a 50 ms cadence. Okay, let's keep creating functions, and eventually we'll be all caught up. We're going to be doing our stop timer this time. This time, we're going to have our timer question mark dot invalidate, which is a built-in method, and then we're going to have our timer equal nil. So it's going to tear down the timer really safely. All right, another function we'll be creating, which is also going to be a private func, is going to be that update visualizer that we had referenced but had not yet existed. This is going to refresh current time and channel power from the player. So we'll have our audio player question mark dot update meters. This is going to recompute any power levels. Then we'll have our current time equal the audio player question mark dot current time, and we can provide a fallback with our double question mark of 0.0. So this is going to publish any elapsed time, great for when we want to display it. Then we'll have our left power, which is going to equal the audio player question mark dot peak power. We can just do the for channel. Now for this channel, because we're doing the left power, it's going to be the channel 0. Outside of the brackets, we can provide a fallback with our double question mark of negative 160. Essentially, this is just controlling our left channel dB, and we'll be creating something very similar for our right power to equal the audio player question mark dot peak power. And this time for the channel, it's going to be the number 1. And let's also set that fallback to be 160. Okay, 2 more functions that we'll be implementing a little bit later on, but might as well create them now so we can get it all streamlined. We'll be creating a function to jump to a specific playback time in seconds. So let's call this function seek. And in the brackets, we're going to have this go to time, which is conforming to a time interval. Go ahead and add our brace, and we'll just have our audio player question mark dot current time, and it's going to equal the time that we're passing through in the function parameters. Now it's time for our last function. I promise we're going to be updating the output volume. We're going to create a function and we'll call it set volume. In our brackets, we'll do underscore value, which is going to conform to a float. We'll add our brace, and we're going to be looking at our audio player question mark dot volume, which will equal the value. So essentially it's going to update any output volume from 0.0 to 1.0. Okay, this is our engine. Anytime you want to change how the kind of player is working, any of the coding logic, you'll want to come here and update any of these functions or add some new functions if you'd like to add any more functionality to your app. But this is our player. Okay, let's really quickly create a view for our bar shape. So let's go ahead and create a new empty file, and we'll call it bar shape. Now we want to create a custom shape that draws a vertical bar to be scaled from 0 all the way to 1, and we can use magnitude for that. We're going to start off with our imports, and we'll be doing SwiftUI, and we're going to be creating a structure. And we'll give it the name of bar shape, but it's going to conform to a shape. Shape lets us describe a path procedurally. SwiftUI can re-render it as any magnitude changes. We'll add our brace, hit return a couple times, make some space, and let's create a constant of magnitude. And this is going to conform to a CG float. Okay, and within the structure, let's create a function. And we're going to call it path. With path, you want to include the in, where we're going to have a CG rectangle, and then return a path. Essentially, we want to compute a rectangle whose height is a percentage of the available rectangle. So we'll create a variable of path, which will just equal path with a capital P with the empty brackets. Then we're going to establish a height. This is going to equal the rect for rectangle dot height, and we're going to multiply it by the magnitude. Trust me, when you see it in action, a lot of this tends to make more sense, but we essentially just set the scale to the available height. Then we'll establish a y, which will equal the rectangle dot height. And when I say rectangle, I mean RECT, the rect, minus the height. This is going to anchor the bar to the bottom. Then we'll have our path dot add rect. And from here, we're going to be looking at the CG rect. Within the brackets of the CG rect, we're going to be looking at the x value. We'll set this to be 0, the y to conform to the y value we just created. We'll also want to include the width, which is going to be the rect.width, as well as the height, which is going to conform to the height value. Essentially, we're then going to be drawing the bar. So the only thing left to do now is to return the path. So this lets us control the bar's height dynamically as the sound levels change on the left and right bars. We will need to establish two different ones, but that's totally fine. Okay, now in our content view, we're going to be putting it all together. We're going to start with a really simple content view in order to just get the playback working, seeing our bars visualize. Then we're going to add all the bells and whistles after. Okay, let's go ahead and axe our placeholder here. We don't need that VStack yet. Under the structure, we're going to be creating a state object so we can share the audio engine with the view so any of the UI can react to its published properties. So we'll create a state object, call it private var of, let's just call it engine, right? If you want to call it audio engine to be more specific, you can, which is going to equal our audio engine class. Okay, I'm going to start off with a ZStack to add a gradient. I'm just going to go ahead and in the object library, Command-Shift-L, grab a linear gradient. What colors am I feeling? I've been a huge fan of the purple and orange, and then leading and trailing is probably fine. We'll set this to have the edges, ignoring safe area, to be all. Go ahead and check that out in the canvas real quick. Perfect, that looks pretty cool. Okay, let's then add a VStack, and this is where we're going to be having our toggles between the play and pause. We can do our toggle with a button. Now we're going to do the button with a label since we're going to be using those system images here. In the braces of the button, we're going to have our engine, and we're going to be referencing the dot is playing, and then we can add our ternary operator. We do a question mark, engine dot pause, add our colon, and then our engine dot play. So this will allow us to toggle on between playing and pausing. Now at the end of the brace of our button, we definitely need to add a label. It's pretty mad at us. Let's go ahead and do that. But we'll add an image, and like I said, we can use those system names. And we can have this string be based off of whether it's playing. So we can again use our ternary operator of our engine dot is playing. So we can add pause dot fill. Actually, let's do the pause dot circle dot fill. That one looks a little bit better. And then our else with our colon will be the play circle fill. We can even add some font styling to this. I want them to be pretty big, so I'm actually going to set it to be a system size of 80. You can play around with this, of course. And I'm going to set the foreground style to be white so it pops off the background. Okay, cool. Still within our VStack, we're going to now add an HStack. And in this HStack is where we're going to have two simple bars whose heights are going to scale with those normalized power. One for the left and one for the right. Let's add a little bit of spacing in this HStack before I forget, and let's make it like 16 so the bars have a little bit of wiggle room between them. Okay, we can reference our bar shape and our pass-through of magnitude from the bar shapes with file structure we had created. It's asking us for a CG float. We're going to be putting in normalized. From here, we're going to be looking at the engine.left power. Now we can also add a frame here if we want to customize how these bars look and feel. I'd recommend doing a width and height. So for the width, let's set it to be 40 for now, and the height we can do 120. Always feel free to adjust these numbers, they're totally arbitrary. Let's also set a foreground style. So for my left one, I'm going to set this one to be blue. Now you notice we don't have normalize found in scope, so let's go ahead and add a function. We're going to go all the way down right before our last brace, and we'll add a function called normalized. This is going to map any decibel values from 0 to 1 for drawing. So from here, we're going to have our brackets inside underscore power, which is going to be a float, and then we're going to be returning a CG float. Go ahead and add our brace. So we're going to have a minimum dB, so let's call it min dB, which is going to be a float. And let's have it equal -60. Then we'll have our normalized, which is going to equal the equation of power minus min dB. And we're going to divide that with an equation over here within brackets of 0 minus min dB. Then we're going to be returning a CG float. And we're going to be looking at the max. We're going to add another bracket 0, comma, min, normalized, comma, 1. Cool, so that should be our normalized function. Let's go back to our bar shape and let's go ahead and copy it. And we can paste it, and this time for the engine, we're going to be looking at the right power. I would keep both of these the same, although maybe change the color. So let's set this right one to be, I don't know, red. I think that should work. Something I definitely recommend doing with these bars is animating them. So outside of the H stack here, I definitely recommend adding an animation. Let's do ease out. And then let's change this up a little bit. We can have a duration of 0.05, and that should line up with our polling. And the value can be based off of the engine.left power. So this should allow for smoother meter updates. Okay, let's go ahead and put it all together. I'm going to refresh our canvas and we should see all of our beauty in action. Again, this is the most simple version of this. We'll be expanding it to the example you saw in the intro afterwards. Okay, and we can see that we can pause and play our app in the preview. Let's also just run it on the simulator real quick. If it works in the preview, definitely work in the simulator. Just as a note, as this is loading up, if you open up the simulator and go to I/O, you can go to the audio input as well as output. So I'm going to set mine to be my AirPods, just so when we're practicing or testing, we're making sure it's going to the right stereo. And here we have it on the simulator. Let's go ahead and press play. Might take a second to load sometimes on the simulator, but we can see that we have our bars updating in real time. We can see that as the left and right are changing, they're kind of like hopping up and down, which is pretty cool. So next step, we're gonna glamify this. You can of course feel free to do whatever design choices. Again, you can add like treble, bass, and all the different levels that you're tracking to make an even cooler visualizer than this, but this is just how I would do some of those changes. So let's go ahead and stop running this and upgrade our content view. We're not going to be touching the engine anymore, just the content view from here on out. So first off, I'm going to be replacing the static background for an animated one. I love an animated background, it's kind of a problem. So you can create this in another file if you really want. I'm just going to put at the end of our content view outside of all of our braces. We're going to create a struct of animated background, which is going to conform to a view and a brace. And we're also going to want a variable body of some view. Again, typically do this in a separate Swift file here. Let's go ahead and establish a variable for whether or not it's playing. And this is just going to be a Boolean value. This way, when it's playing, we can have it be animated. When it's not playing, it could be static. We'll also create a state private var. And let's have it be animate. And by default, we'll have it be false. All right, in our view, we can add our linear gradient. Again, I love doing my Command-Shift-L to go to the Swift object library and grabbing the linear gradient because I'm way too lazy to ever type this one out. Okay, inside of our placeholder colors here, so our array of gradient colors, we can go ahead and have this be an animation. So we're going to have our animate, we'll add our question mark, and then we can include some colors. So for the first one, I'm going to be doing my orange, and then we'll add our colon, and then let's do purple. We'll add a comma, and we can add another animation. We'll add our question mark, and this time we'll do pink, and then after our colon, let's do blue. These colors are completely arbitrary. Whatever colors you want to add, feel free to do so. Outside of our gradient, we're going to add a dot on change. And this is going to be based of, let's do it for the is playing, which is that Boolean flag for whether or not the music is playing or not. We'll add a brace and we'll say playing in, and this is where we'll handle our start/stop background animation with playback. So if it's playing, we can add a brace here. We can have with animation, we'll have, let's do ease in, out. We can also include a duration. And let's have this be 2 seconds. And we can set this to be repeat forever and an auto reverses to be true. Just add a little bit more style. We then add a brace in here and we'll be setting our animate to equals true. Then outside of the if, we're going to add our else. So whenever we're not animating, we can have our with animation once again. And we'll put this to be dot ease out. Include a duration. Let's make it 1 second. We'll kind of have it fade a little bit more quickly. This is going to allow us to smoothly return to the static color when paused. And I'm going to have the animate equals false. Okay, now in our Z stack where we originally had our linear gradient, we can go ahead and get rid of that, and we can actually replace it with our animated background. So we'll do animated background, and for the is playing, that Boolean flag, we're going to be basing that off of the engine.isPlaying. And we should always, just in case, set our edges ignore safe area to be all. Okay, let's go ahead and see this change in action. All right, so we can see when we're paused, we have that purple and blue gradient. And now when we play, we're going to have that gradient that's kind of shifting through the colors, giving it a much more lively feel. And when we pause, it goes back to static. Pretty cool. Okay, next, I kind of like our button for the pause and play, but it feels a little bit basic. And our logic is fine, but let's go ahead and just update the label so it feels a little better. So I recommend adding a shadow. And with the shadow, we have to include a radius. Let's put this radius to be 10. Before the radius though, we can actually include a color. And for this color, I'm gonna have it be white with a little bit of opacity. For that opacity value, I'll do 0.5. Make sure you add a comma afterwards so we can do shadow, color, and then radius. I also like to enlarge it while playing for a little bit more feedback. So I would include a scale effect. And within the parameters, we can have this be based off of the engine.isPlaying. We can do our ternary operator. So let's not make it like too big of a change. Let's have it be 1.1. We'll use our colon for else. I love me some ternary operator, honestly. So the other case, it would be 1. So a very slight enlarge just adds a little bit more feedback. Speaking of feedback, let's add an animation. I'm going to go with the spring. And for the spring, let's have a response. And let's have it be 0.4 or 0.5. That should probably be okay. We can also include a damping fraction. Let's do 0.5 for that as well. Then for the value, let's go ahead and have that once again be based off of the engine.isPlaying. This way we can animate and scale the icon and we can have it change a little bit more. Okay, and we can see it now has that little bit of a glow because of the shadow. And when we press it, we get that little animation. Just makes it feel a lot more alive. So feel free to adjust those values. If you don't like the animation, totally don't need to include it. Okay, next I want to add a scrubber that actually seeks. Before we do that, we will need to create another function. So after our function of normalize, we'll create a function to format time, and we can just call it format time. Within the brackets, we're going to have underscore time, and that's going to be a time interval. We're then going to be returning a string. This way we can render as seconds. So we want like minutes and then seconds. For example, 1:05, pretty like human readable. That's essentially the goal of this one. We're going to have minutes, and the minutes is going to equal an integer of time, and then we're going to be dividing that by 60. Then we also want seconds, which is also going to be an integer of time, and this time we're going to be doing the %60. Then we can return a string. Within the brackets, we're going to have a format. This is going to be formatted as a string, so we'll have %d:0 to d. This is going to allow us to return it in minutes and seconds, again making it readable. Side of the string, but still within the brackets, we're going to have our minutes and our seconds. Okay, let's, in our VStack, after our HStack of the bars, let's add a spacer. And then we can put our scrubber down there. And we'll put these both in a VStack as well. Let's first display the elapsed and total time labels. So immediately in our VStack, we're going to be adding another HStack here, and we'll have our text, and we'll have our format time, and we'll have our engine current time. We'll then put through a spacer, so it pushes it to the kind of other side, because I want to have my total time. So it should on the left display what time we're currently at, and then on the right, what is the maximum time. So we'll have our format time again, and we're going to have the engine dot duration. So that's like the entire duration of the audio clip. We can include some font stylings here. So let's do a font, maybe caption, and a foreground style of white. Now after the HStack, we can then include our scrubber, which is going to be a two-way bind where we can call seek on dragging. So we'll create our slider, and the value is going to be based off of capital B binding. Now for this binding, we're going to add some custom logic. So I'm going to add a bracket after the binding and hit return so we have a little bit more space. We're going to be doing our get and our set. So I'm going to choose the autofill here. For our get, we're going to add our argument braces. We're going to be looking at the engine dot current time. For our set, we're going to be looking at, with our braces, the new value in, return a couple times, and we're going to be looking at the engine dot seek, and for the to, the new value. This is going to allow us to jump the playback position. Okay, and outside of the brackets of our binding here, you might want to do the little double click trick so you can find out where we are. We're going to add a comma, and we'll say in, and our colon, and we're going to give it a range. And for that range, we're going to do 0, ... And we're going to be looking at the engine dot duration, which essentially just goes from the very beginning of the playback to the total duration at the end. Okay, there's a lot of brackets going on here, but outside of that one, feel free to add some tint, and I'm going to do mine as cyan. I think that's like blue or cyan's a pretty common color for any playback scrubbers. All right, let's go ahead and test these out real quick. Okay, the spacing might have been a little bit overkill. But we can see all the way at the bottom our scrubber, and we can move it around. And depending on where we want to go in the song, and then even on the left and on the right, we can see the current playtime. And when we pause, it no longer moves. You know what, outside this VStack, let's add a little bit of padding. It's pretty funny right now. So let's add some horizontal padding so it's not on the side. Let's set that to be 40, and let's also do some vertical padding, or actually bottom padding, probably also as 40, so it's not like totally totally cursed. Okay, after this slider, let's also add a slider to control the volume, and this one's going to be built very similar. So we're going to have our value also be binding, and we'll add our custom bracket here, hit return, and we're going to be wanting to get and set. So for the get of the volume slider, we're going to add our brace, and we're going to be looking at the double, and then the brackets, our engine dot volume. Then for our set, let's go ahead and add our braces. In here, we're going to be looking at the new value in return a couple times, and we're going to have our engine dot set volume, and then for the value, it's going to be a float, and add another pip, add some more brackets of that new value. Okay, great. After the brackets of our binding, but still within the slider, we're going to add a comma. We're going to add a range. So we'll use in, we'll use 0, dot, 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 1. So from 0 all the way to 1, we're using that decimal value. Let's go ahead and also add a tint, and I'm going to set this one to be green. Okay, let's go ahead and see our slider control in action. Okay, much less cursed. There we go. So we can hit the play button here. Sometimes on the simulator it lags a little bit. Okay, there we go, and let's move this down, and it gets so quiet, and if we go all the way down to 0, we can't hear it anymore. We can still see that it's playing. And we can go all the way back up. We can do a little bit of DJing here, but there we go. We've added the volume control slider. The only thing is we can update this, and it'll be blasting. Pretty cool stuff. Okay, not a whole lot to add. Really, we're pretty much done with the audio player here. Might want to go back and actually fix some of the spacing, because yeah, it does look pretty funny. But yeah, we are pretty much good to go. The last thing I'm going to be adding is our volume bars. They're currently a static color. I'm going to make them look a little bit better by doing a really quick kind of gradient bar that looks a little bit nicer. Okay, we're going to scroll all the way down to the bottom. Again, I recommend just doing this in a new SwiftUI view, but I'm being the utmost lazy today. We're going to be creating a new struct, and we'll call it dynamic bar. It's going to be a view, and we can use our autofill to save a little bit of time. So we're going to need some constants here. We're going to have a color 1, which is going to conform to a color, and a color 2. If you really want to get like super crazy with your gradients, feel free to add as many colors as you'd like. Then we're going to create another constant called power, which is going to be a float. And then we're also going to have our normalized, so we'll call it let normalized, which is going to be a CG float. Again, it's going to be our range from 0 to 1. In the variable body of some view here, we're going to be creating a Z stack. Immediately afterwards, we're going to have a VStack, and this is going to hold a geometry reader. We'll then put our geo in, and within the geometry reader, we're going to have a height, which we'll establish as the geo.size .height, and we'll be timesing that by our normalized value. Then we'll create another VStack here. We'll put a spacer, and within the brackets of the spacer, we're going to put a min length of 0, and then we'll have a linear gradient. For the colors, we're going to have color 1, comma, color 2, and if you added additional colors, include them here, obviously. For our start point, let's have it be the bottom, and for our endpoint, it will be the top. Now this is the styling I'm doing. You by no means need to copy it. We'll add a frame to this linear gradient, and we'll have our height be based off of the height value we just created above. And then we can also add some corner radius. You know what? I love me some corner radius. We can also do a little bit of a shadow with a small radius as well. And we can add an animation. From here, I probably do the interpolating string. And within the brackets, we can have some stiffness. And we can set this to be 120. I typically also like to add some damping as well, and I'll add it as 14. Get rid of this other placeholder here, and we need to be making sure that we have it based off of a value. So that value will be normalized. Okay, outside of the geometry reader, but within that first VStack, under the Z stack, we're going to add a rectangle here, and we'll add a fill property. Within the fill property, we're going to add a linear gradient, and we can add our colors. And we're going to, inside of here, put a color 2 with a really low opacity. So let's do like 0.2. Then for the second color, we're going to have that one be clear. So dot clear. For our starting point and end point, I'd probably start it at the top. And for the endpoint, probably at the bottom. Again, your app, you can design it however you want. And as a little bonus, let's go ahead and add some blur with a radius of like 2, just make it like super clean. Okay, and then at the end of our Z stack, we're gonna go ahead and add a frame with a width and height. Let's set the width to be 40 and the height, let's do 200 here. Then we're gonna go to our bars. We're gonna scroll up or find them in our content view where we have our H stack with the bar shape. And we're gonna be replacing them with our cool new dynamic bars. So let's go ahead and delete them and reference our dynamic bar, and we can pass through a color 1 and 2. So I'm gonna do for the first color green, and then the second one maybe cyan. I want like a kind of neon kind of retro style. For the power, this is going to be based off of the engine.left power. And for our normalized, that's going to be our normalized. We're going to pass through the power of the engine.left power. Okay, we can go ahead and either reference it again or just copy and paste. For my second one, I'm going to do pink and indigo. And then I'm just going to update this to be the right power for the other bar. Okay, let's see our animation and our changes in action, and then we should be all good to go for today. All right, and here is our player. I'm just going to reduce the volume a little bit ahead of time. So we can see now we have those cool new playbacks, and look at that. It kind of has that glassy effect at the bottom, so it looks like it's kind of reflecting on the surface. Tell me that isn't cool for the player. I definitely still need to go ahead and actually fix the spacing on this view. Our player's all the way up here and then our script is down here. Either way, we can fix that. But this has been the playback visualizer. Now, if you want to download this version, you can actually fork and create your own copy from my GitHub repo. The GitHub repo will be in the description below as always, and you can check out any other project resources I have created before and will continue to create. So if you enjoyed today's video, please give me a like, thumbs up, all that good stuff, and leave a comment if you need a little bit of help, or leave a comment to let me know how you're going to be planning on adding this visualizer or a variant of it in your app. It's pretty cool and fun stuff. I really do like having audio playback. When I was thinking of making this video, I don't remember if it was QuickTime Player on really old Windows. I remember you would play music, totally didn't get it from LimeWire back in the day, and you would have like this cool like visualizer that was like really trippy when you thought about it, very like tie-dye. So maybe one day I'll go ahead and try to recreate something like that. I'd have to find out what it was actually called. I feel like it was QuickTime Player on Windows, like Windows 95 or Vista or something. But that's what I was thinking of, and I was like, you know what, I'll just do the animated gradient background for the colors, and we'll just have our left and right bars just kind of hang out and visualize. You can change these bars up based off of the previous demo where we did like the treble and the bass and things like that. Add as many as you want, even label them. Yeah, this was a pretty fun one to make. I had been doing so many things about audio input visualizing that I was like, hey, I haven't done anything for output visualizing, so it was definitely overdue. But yeah, hope you enjoyed the tutorial. Of course, check out the links on GitHub. I'll also put the link to any of the resources we used today in the description below. Otherwise, dream big, code bigger, and have an amazing rest of your day.